we now look at collisions in 2 dimensions with extended bodies. So previously, collisions in 2 dimensions were for point sources, objects that could not physically rotate. But now we're going to look at what happens if those objects can rotate. So in a collision, both linear and angular momentum are conserved, assuming, again, no outside forces or torques act on the system. So outside forces or torques are objects that, again, once you define your system, any object outside of that system acting on your system can provide an outside force or an outside torque. Linear and angular momentum are both vectors, so direction matters. And this is a 2-dimensional body, so typically the problems that you'll be dealing with, an object can have 2 linear dimensions, an x dimension and a y dimension, and angular momentum will be about some fixed axis in one of those 2 dimensions. So angular momentum will give you one set of equations, what's the rotation about some fixed axis, and linear momentum will give you 2 sets of equations, what is the linear momentum in the x direction, that has to be conserved, and what is the linear momentum in the y direction, which also has to be conserved. Kinetic energy, we've learned, has both a linear and rotational component as well, but kinetic energy is a scalar, which means that the total kinetic energy before the linear and rotational kinetic energy before must equal the total kinetic energy after in elastic collisions. If the collision is not elastic, then the total kinetic energy initially will be larger than the kinetic energy after the collision, the total kinetic energy after the collision. So if it is not an elastic collision, then kinetic energy is not conserved. You can calculate how much it changes, but you can't assume that it stays the same. If the collision is elastic, you can. Linear and angular momentum is conserved regardless, again, assuming no outside forces or torques act on the system. So when you're solving these types of problems, these extended bodies in 2 dimensions, make sure you realize, is it an elastic collision or not? Maybe you're asked to calculate what the kinetic energies are before and after to find out if it's an elastic collision. If they tell you it's an elastic collision, you can use the total kinetic energy before is equal to the total kinetic energy after. If they don't, or they say it's inelastic, and you're out of luck with these equations, you have to use your angular momentum equations and linear momentum equations. Linear momentum will be 2 axes, again, x and y. Angular momentum will be about some rotation axis. So set up those equations and solve for your unknown.